The mighty rubber band, the source of all energy and power for the rubber band race car. All right, seriously. So this series of video, this is the first of two to explain how to do the force and energy lab. So this video is really just to give you the background information to understand how we think of energy being stored in a rubber band. And the best way to understand energy stored in a rubber band is to go back to something that I think most of you already know. And this idea is that energy is transferred, energy is also conserved. So I know that a lot of you have maybe done roller coaster projects and things like that that dealt with potential energy and kinetic energy and how it is transferred back and forth. So the idea here, just as a quick review, if I take this ball and I lift it up to a certain height, it's going to have what we call gravitational potential energy. This is energy held in readiness, that if I just let this go, it has the potential to fall back down to the earth, and all of this potential energy is transferred into kinetic energy without any losses. So energy is conserved. The rubber band is the same thing, and we can kind of think of it as like gravity as well. So if I kind of hold one end of the rubber band, as I stretch it up, much like lifting the ball up in the air, now this has potential energy, but we wouldn't call it gravitational potential energy. We would call it elastic potential energy. So when I let it go, it snaps back down, and that energy is transferred into kinetic energy. What makes it more interesting, and maybe related to the car, I'm going to use a different rubber band here. Okay, I got my big rubber band, okay, a little bit different. And I have my $100 eraser. So now if I put it inside the rubber band and I stretch it back and give it elastic potential energy, well, as soon as I let it go, oh, wow, you couldn't even see that. That was so fast. All of that elastic potential energy has been transferred into the kinetic energy of the eraser as it went flying across. So that's what we're going to be looking at, the transfer of energy. So our goal is to determine the energy that's going to be stored in this stretch rubber band. So if I get a bunch of elastics out here, I have a lot of different kinds of rubber bands. All these different kinds of rubber bands will have different stretchiness. And the way we characterize it, something like this is a hairband, how much force do I need to apply from my hand to stretch it a certain amount? And I can tell you this one's like really hard to stretch, like from here to here, like about an inch. Our rubber band for our car, I can tell that if I stretch it just about an inch, I really don't have to pull on it much at all. And in fact, this big one right here, stretch it an inch, it's even less. So all these different elastics have different ways, different properties to characterize it. We call that property the spring constant. And basically that is K, we call it the spring constant, and it's basically how stretchy something is. How much force would I need to apply for a given amount of stretch? So the energy equation for this, energy stored in the rubber band, is going to be equal to 1/2 K, which is the spring constant, times x squared. Now this x, I know we've used it before to stand for position, but for this formula, it means the amount that we stretch it from its regular state. So right here, this would have 0 stretch, x would be 0, but then as I stretch it more and more, I would measure the distance from here to here. That's how much it's stretched. Now the next lab, the next video, is how do we determine this value of the spring constant. So good luck.